Mr. Quinn, what are we going to do today in the world of mathematics?
Well, Mr. Hartung, in math intervention, we've been working on factoring some some numbers into their primes. And so I have a list here of some of the primes that we're going to be factoring today. And a lot of them have little rules that go along with them. And you can follow those to just know if something can be divided by 2 or 3 or 5. Now, notice that not all primes have rules. 7 down here, it's a mess. There's not much you can do to recognize that 7 goes into something. But what we're going to be doing is we're going to be taking these rules, and you can see that if it's divisible by 2, it ends in an even number, and I have a list of evens here, 0, 2, 4, 6, and 8. If it's divisible by 3, then what we're going to do is you just add all those digits together in that number. And if that number that's left over after you've added them all together is divisible by 3, so is the original number. Now 5 is nice and easy, ends in 0 or 5, really quick to check. 7, again, there are no rules. And 11, this is only for two-digit numbers. If it has 2 of the exact same numbers, it's divisible by 11. And so if you see a 77 or an 88 or a 99, things like that, where it's got a 9 and a 9, 7 and a 7, and so on.
So like 199?
Well, that's why I said if it's a two-digit number. So it's only going to be from 11 through 99 where it works.
I got it.
All right. So today's number that we're going to be working with is 2,310. And I'm going to be using these rules to figure out what goes into this and how we're going to factor it. So right off the bat, we can see that it ends in a 0. And if we're looking at this rule for 2, if it ends in an even number, 0, 2, 4, 6, or 8, then it's divisible by 2. So 0 appears on this list, and it's also what it ends in. So I know that 2 goes into this number. So I'm going to make a little factor tree here, and I'm going to put a 2 there. Now the way I figure out what number goes here is I just take 2,310, and I'm going to divide it by 2. Well, 2 goes into 2 one time. Bring our 2 down here. It's 1 times 2 gets this number. Subtract and we get a 0. And now let's bring down the 3. And 2 goes into 3 one time. Doesn't go in evenly. 1 times 2 again gets us this 2 down here. And we're going to subtract. And 3 minus 2 is 1. Bring down this other one. And we go, oh, that's 11 now. Well, 2 goes into 11 5 times. And that gets us a 10. Because again, 5 times 2 gets us that 10. We're going to subtract here. And we have, well, you can fix that in post. Just slow it down. My voice will get deep. All right. So we did the 2 times 5 to get us this 10. Now 11 minus 10, that just has a difference of 1. So we bring that down here. And we have 2 going into 10 how many times? Well, that's going to be 5 again. So 5 times 2 gets a 10, and we have a remainder of 0, which is what we wanted. We want that 2 to go into that number evenly, and it does. So again, all I did here was some long division steps. 2 goes into 2 one time. That left us 0 here, so we just brought down the 3. 2 goes into that one time again. And again, to get these numbers down here, you're just multiplying the 1 by the 2. That gives us a 2. That gives us a 2 again. Here's where we get our first remainder, and it's a 1. We bring this 1 down, and we've got 2 going into 11 5 times, because it goes into 10 evenly. So 5 times 2 gets us 10. When we subtract those, we're left with 1. And we just bring down this 0, and we've got 10 again. Well, we know that 2 goes into 10 from this step right here. It goes in 5 times. So now we can see that this number is going to be filled in with 1,155. Now, looking through these, we're going to pick something else. What else goes into 1,155? 2 doesn't anymore. This doesn't end in a 2. It doesn't end in a 4. It doesn't end in a 6 or an 8 or a 0. So we know that 2 is not going to be involved in this. But if we look at it, we've got a 5 here, and it ends in 0 or 5. Well, this does end in a 5, doesn't it?
Yes, it does.
All right, so let's put a 5 right here. And let's start this process over again. But instead of working with this original number, we're just going to work with this smaller one here. All right, so now you guys are going to be dividing 5 into this number here. And so does 5 go into 1 evenly?
No.
No, it doesn't, right? So we're going to be looking at 5 going into 11. Now, how many times do you think 5 goes into 11? Good job, Jackie. It is 2 times. Now, 2 times 5 gets us to this 10, and we're just going to subtract. It's the same process as this side here. And that gives us a remainder of what?
1.
It does give us 1.
So 11 minus 10 is 1.
That is what I'm saying, yeah. I would agree with that statement.
I concur.
Now we're going to bring this 5 down, and what number do we have there?
I think that's 15.
That is 15. Now it's difficult to tell. My handwriting's not the best. But how many times does 5 go into 15?
So 5 times some number equals 15.
Yeah. We're looking for what that number is.
5. 5 times 2 is 10. 5 times 3 is 15. 3.
There you go. Good job, Mr. Hartung.
Thank you, Mr. Quinn.
And like you just said, that gets us 15 even. So we're going to subtract here. And what's 15 minus 15?
I believe today it is 0.
It is 0 most days even. We're going to bring that 5 on down. And how many times does 5 go into 5?
How many times 5 go into 5 or 05?
Well, 0, 5, because the decimal would be back here. That 0 actually doesn't change this number.
So I could ignore.
You could ignore that 0.
I'm thinking that 5 times 1 is 5. 1.
Yeah, let's put a 1 there. Now 1 times 5, like you said, is 5. And we get a remainder of 0, which again is what we wanted. We want that final remainder to be 0. If it's not 0, then 5 doesn't go into that number, and we messed up somewhere. But you found that it does, and we get 231. Now, just looking at this number, we've tried 2 and 5, but this doesn't end in an even, and it doesn't end in a 0 or a 5. So we're not going to use that 2 or that 5, but what else do you think we could use? What do all of these digits add up to? What's 2 plus 3 plus 1?
Looks like 6 to me.
That is going to be 6, right? Now, is 6 divisible by 3?
Yes. 3 times 2 equals 6.
Yeah. And this rule states that if all those digits add up to a number that's divisible by 3, then it's divisible by 3. So we're going to divide it by 3. So we've got this 231 dividing it by 3. Now, does 3 go into 2?
Well, not evenly.
Not evenly, and that's what we're looking for. We want it to go in at least once, and it would only go in a fraction of that. So you can put a 0 up here. If you don't want to, you just have to remember that the next number you write is going to be above this 3. So how many times does 3 go into 23?
3 times 5 is 15.
Yeah, we looked at that up here.
6 is 18. Times 7 is 27. 7 times 3, 21.
7 times 3 is 21, so we'll put a little 21 there. And we're going to subtract it, right? 23 minus 21, what is the difference there?
I'm thinking 2.
It's going to be 2. Now, let's bring this one down. And we've got a 21 there, and you actually just told me, right?
Yes.
You told me that that goes in there how many times?
7 times.
7 times. We've got a 0 again. That's what we wanted, right? That means 3 goes in evenly. And we're left with a 77 here. Now, 77...
Hey, that's a 2-digit number.
That is a 2-digit number.
2-digit number, double 7s.
Yeah, with the same digits, right?
And that fits in with that 11 rule.
Yeah, so let's take this 77 and let's divide it by 11. Now, this is something we haven't seen. So far, it's just been single-digit numbers we're dividing by. But now we're dividing by a double-digit number, and so we're just going to have to skip this first one because it's not going to go in there, right? Because you couldn't fit 11 into 7 things. You'd get a fraction again, and we're looking for whole numbers here. So what do you think we could multiply 11 by that would get us 77?
You know, I always liked these in the math class when I was like in the 4th grade. 11 times 7 is 77. 11 times 8 is 88. 11 times 9 is 99.
And if you wanted to multiply that out, you could see 1 times 7, that's just 7. 7 times 1 here again, that's just 7. So we've got 77 minus 77 is 0. And again, that's what we wanted. So we've got an 11 here as well as a 7. Now, in our class, it asks us to write it out as a product of those. And so we could say 2,310 equals. And what we're going to do is we're going to look for these prime numbers here. And a prime number in your factor tree is just going to be something that you can't factor anymore. It's something that only 1 and itself go into. You can't break 2 down into 4 times 3, anything like that. You can only break it down into 1 times 2. And so if you have a number by itself here, and it's not branching out any further, that's a prime. So we're going to go with 2 times. Now, is this a prime? No, it's not, because we broke it down further. 5 goes into it. So this isn't a prime. We get to ignore that. Now we're going to be coming down here, and we've got that 5. Now that 5 doesn't have anything branching off of it. Is that 5 a prime?
Yes.
Yeah, it is. So we're going to write that there, and we've got 2 times 5. Now, is this 231 a prime, or were we able to divide it?
It is not prime. We were able to divide.
Yeah, we divided it by a 3 here. Now, is that 77 going to be written somewhere? No, we broke that down into 2 other numbers. And so we're going to write these other 2 primes down here, and we have solved that problem.
So, what you're telling me then, is this what we call prime factorization?
Prime factorization. We're breaking this number down into the smallest numbers that when multiplied together will make this number.
So you're telling me then that the 2
that's 2
times the 5 times the 3 times the 11 times the 7 will equal 2,310.
Yeah.
Does it matter which way I multiply, which number I use first? Can I do 3 times 11 times 7 times 5 times 2?
Well,
or 5 times 7 times 11 times 3 times 2?
Let's check that out on a smaller scale. Because let's say we've got 2 times 5 here, but we have 5 times 2 over here. 2 times 5 is what?
10.
10. And 5 times 2 is what?
10.
So did it matter what order we multiplied in?
No, we've got the same product, or the same answer.
You could rewrite this however you want using these numbers. We could have gone smallest to largest, largest to smallest, anything in between. So happens we chose a little mix match there.
So, Mr. Quinn, is there a mathematical name for this rule where you can reverse the numbers and still get the same product?
Yeah, it's going to be called the commutative property. So it's spelled like that, Commutative just means that we can multiply in whatever order we want. It also works with addition.
Oh, so if it was 5 plus 2, would be the same as 2 plus 5.
Yeah.
But not for subtraction and division.
No. So again, we started out with this large number. We factored it into its primes that when multiplied together will just bring us right back here. And it's going to be pretty useful in Algebra 1, Chapter 8 is what I'm told by Miss Smith. So thank you for watching. I hope this helps.